All right, with absolute value inequalities, we're basically combining what we did yesterday with absolute value equations and then regular inequalities and just creating this like ultra transformer type thing as far as absolute value inequalities. On your notes, you probably don't have colored pictures, just because copying in black and white and all that stuff. But on here, um, we have a disjunction and a conjunction drawn. The conjunction is the blue part, and that's what's showing right here, that all these values, if you take the absolute value of it, are going to be smaller than 5. And they're connected, right? And then for disjunction, they're not connected. Just like yesterday, the disjunctions, the ors were not connected, right? Those are the things that look kind of like this and all that stuff. Those are not connected as well, and that's everything that's either going to be bigger than bigger than 5 this way when we take the absolute value, or bigger than 5 when we take the absolute value that way. So similarly here, if I want to make conjunction, if I want this to be more than 2 or less than 2, well, conjunction, that was the part that's connected. So here, that's the part that's connected down here. I want that to be smaller than 2. And so then my other one, obviously, disjunction, that would be this part, would be greater than 2. The next part of the notes is something that's pretty important as far as just getting our head around something. No matter what number I plug into x, I could pick 10, I could pick negative 100, I could pick 1,000, whatever, it's still going to be bigger than negative 2. So that would be all real numbers, infinitely many solutions, whatever you want, but it's just going to be all the numbers you could possibly think of, put it in there, fractions, whatever, it's going to be more than negative 2. For here, we can't put whatever we put in there, it's not going to be smaller than negative 2, right? Because the absolute value of anything is still positive. So for that, we're going to say no solution. That's kind of a weird thing, and that'll come back here in a second. The next part, you might want to write that down. You can go ahead and pause it and write this down. I'm going to work the math over here. First thing is to get the absolute value by itself. So absolute value of 3 plus 2x is greater than or equal to 14, right? We added 4 to the other side. Determining if it's an or an and. In class today, we talked about how if it's greater than, it's actually greater than, and if it's less than, sorry about that, if it was less than, it's actually less than. So great or less than. This time it's a greater than symbol, so it's an or. Next thing we're going to do is rewrite it twice. So 3 plus 2x is greater than or equal to 14. And then here's where we change stuff. 3 plus 2x is less than or equal to negative 14. We flip the sign and make it negative. So pay attention to that. Next thing I do is solve. So I'll go down here and solve both of them. So 3 plus 2x greater than or equal to 14. Move 3 over. So I get 2x is greater than or equal to 11. Yeah, subtract. Is that right? Yeah. Subtract 3 from both sides. Sorry, folks, I made a mistake. That should be 13, not 14. I'm dumb. My bad. There we go. So when we subtract that, 3, it's going to give us 10. Good grief. My bad. So then x is greater than or equal to 5. Same thing over here. We subtract 3, so I get 2x less than or equal to negative 16 divided by 2. And x is less than or equal to negative 8. So the last thing says to rewrite right here, solve and rewrite as an or. So x is greater than or equal to 5, or x is less than or equal to negative 8. Boom, boom, and boom. That's essentially the whole lesson as far as what we'll be doing today. I want to work a couple of rando problems just to show and prove some points. Sorry about that. So I got the cold. First thing we do is isolate the absolute value, so multiply by 3. So then I get 2x plus 7 is less than or equal to negative 3. The next step says to rewrite, or we're just going to say no solution. But what about all this stuff? Well, if you refer back to our notes, anytime we have anything over here, and then it's less than a negative number, this cannot happen. Whatever we plug in, it can't be less than negative. So that's why we say no solution. Okay, let's do one more. Number 4 is no solution as well, because when you multiply by negative 2 to get rid of the negative 1/2, that cancels out, and you get the absolute value of x minus 2, and then you flip the sign, less than or equal to negative 6. Once again, it's less than a negative, so can't happen, so no solution. That wasn't the one I wanted to do. I wanted number 5 because it's kind of long. We're going to first isolate, so subtract 6. So I get 9 times the absolute value of 3x minus 2 is greater than 45. Divide by 9. And so I get the absolute value of 3x minus 2 is greater than 5. From there, it's a greater than, so that means it's an or. Next step, rewrite it twice. The first one stays exactly the same without the absolute value bars. The next one, what changes? The sign and the 5. So it should be less than and negative 5. Cool, cool. From there, we're going to add 2 to both sides, divide by 3. So add 2, add 2. You can add 2 over here at the same time if you're really good at math and you're awesome and like to do stuff at the same time. I'm not. I've just done this before, so that's fine. Divide by 3 on all of it. So I get x is greater than 7/3 for my final answer, or x is less than negative 1. That's all those. You can do the other ones if you would like, and I'll see you next time. See you.